Alright students, we're going to do a couple of examples together here so that you get into the flow of it. So in this first part A, we can see that we are given a velocity versus time graph where it's a constant velocity of 2 meters per second. And that exists or occurs for 5 seconds. So let's start with this. Give a verbal description of the motion that includes direction and whether the speed is increasing, decreasing, or constant. So let's say here the object is moving. And you can be typing this on your, or writing it on your own paper while I'm writing this. The object is moving in the positive direction. And that would mean if you were using a motion sensor, that would be going away from the motion sensor. Positive direction, and is it getting faster, or is the speed increasing, decreasing, or constant? And we can say with constant speed. Okay. So we've done the first part. Now the next part is I ask you to show your calculation of acceleration here. Well, I'm asking you to do an acceleration versus time graph here. So we're going to basically be finding the slope of the velocity versus time. So I'm going to show my work really carefully the way I would expect you to show your work. Acceleration is the change in velocity, v final minus v initial, over a time interval. And we're going to use this as our v final. We're going to use this as our v initial. And so here we have 2 minus 2 meters per second. And I'm actually going to do that in black over here. Meters per second, because that's what I try to do with units so they don't get mixed together with variables. And then we have on the bottom 5 seconds. And 2 minus 2, of course, is 0. And 0 divided by 5 is still 0. And looking at the units there, we get meters per second, which we can write as meters per second squared. Actually, that's not a great way of putting the equal sign. Let's just show, I'm going to show that like a little arrow. Meters per second squared. Okay, so for a acceleration versus time graph, and I'm going to do this in red because I use red generally for things related to acceleration, and it's going to be 0 for the whole time. Okay, well now that we have that acceleration, we have basically figured out what the slope of this line is. So down here I ask you to write an equation for the v versus t line. And I'm going to do this in green because it's velocity related. And so as you know from math class, y equals mx plus b is the general equation for a line. But in this case, y is actually v, so it's going to be v equals, and m is the slope of that line, and in our case the slope is the acceleration, and so that's going to be a value of 0, and I'm going to put the units in there as well, even though they're a little bit unnecessary if the value is 0. And then I have times, now in math x would be the horizontal, but in our case here it's going to be t. So times t plus, and now we have to look at the intercept. This is where the y-intercept, or we would call it in this case maybe a v-intercept. It is v0, v at time 0, and we can see that that's going to be 2. So plus 2 meters per second. Alright, so that is an equation for this line. If you want to simplify this, we can simplify it like so. 0 times t is 0, so it's just going to be 2 meters per second. Now, going up to the top part here, so I'm asking you to make a x versus t graph and also draw a ticker tape motion diagram, label v and a vectors. So I'm going to show that it's moving in the positive direction with constant speed. So I'm going to draw these equally spaced. They're not getting fast, not getting faster, it's not getting slower. And you know what? I'm going to step back for a moment, you guys. I can't actually go backwards with my program, but I'm going to do this I only need 5 of these here, because usually when we draw these diagrams, we're drawing it at 1 second intervals, and our graphs only go up to 5 seconds. So this would be like t equals 0, and it's a good idea to label these 1 second, t equals 2 seconds, t equals 3 seconds, and t equals 4 seconds. And then I ask you to draw velocity graphs, and I don't know why those dots just disappeared on me. Let me see if I can bring them back. Dot, dot, okay. So we're going to put a little V, let's try it again. Well, okay, it's doing weird things on me. There it goes. So I'm drawing all these V's the same length because it's not getting any faster. And I'm going to now also include an acceleration vector. I'm going to draw one acceleration vector showing the direction that the V is changing. And actually, because there is no acceleration, I'm just going to write this, a equals 0. All right, now, how do we find out what the position versus time graph looks like? So here we're going to use this concept that we learned about shading underneath the graph. So I'm going to use my highlighter here, and I'm going to shade under that. That was a little bit sloppy because it goes too far down. So I'm going to do it this way instead. I'm going to shade in that space in there. And basically what we're trying to do is we're trying to find the area under the curve there. So let's take for 1 second. In this 1 second time interval, because it's moving 2 meters per second, it's going to move 2 meters. So what we can do right here is go V, let's see here. Yeah, we're down here. Show your calculation of x. So the displacement is going to be equal to the speed it's moving times the time interval for it. And the speed it's moving is this speed right here. So that's 2 meters per second for a 1 second time interval. So it would be 1 minus 0 seconds. And that means it's going to go 2, and what are the units going to be? This seconds cancels with that seconds, so we're going to get just meters, this unit right here. So I know that after one second, it's going to go 2 meters. So I'm going to put a label here, 2 meters. I'm going to do this in black here. All right, 2 meters. Right there. So far we know that it's 0, 0, and then here is 2 meters. Okay, now for 2 seconds, I'm going to ask that you guys split it up. So I did the one for 1 second. You would have someone else in your group do it for 2 seconds here. And the displacement that they would calculate, I'll do it in black right next to this one here. Displacement equals velocity times time. Now the velocity that we have to use here is, this 2 that we have going across there. This time is going to be times 2 seconds. And so that's going to be a total of 4 meters per second. And I got 2 seconds here. Let me clarify that. That was 2 seconds minus 0 seconds, because this along here is a 2 second interval. Alright, so we get 4 meters. So at 2 seconds it's going to be up here 4 meters. So our scale here is going to be 2, 4, 6, 8. And I may have made a scale too small, because I can see already that when I get to 5 seconds out here, we're going to be off the scale. And so I'm just kind of jumping ahead. What you should be doing is each person in your group should calculate one of these data points, and then drawing a fit to that. Oops. Uh-oh. Okay, so what we can do then at this point here is we can, oops, that should be a straight line. I'm doing this with the mouse. So we can draw either a straight line if they're a straight line, or a curve if they happen to be a curve. The basic thing to remember, guys, this is the star for how to find the x position, is how far it gets is equal to the area under the v versus t graph. And if this v versus t graph is a triangle, then you're going to have to find the area by doing base times height divided by 2. Okay, so work together, as I know that you guys can do effectively. And we will go over your work tomorrow. Have a great day.